Hello everyone, welcome to the Chemical Safety Technology course. I am your instructor, Suo Yanbo. In this session, we will explore safety accessories for pressure vessels. Workplace safety is closely tied to the lives and property of the people, as well as to the overall interests of reform development and stability. The importance of workplace safety cannot be overstated. Ensuring workplace safety must never be neglected at any time. Against the backdrop of continuous technological advancement, pressure vessels have evolved significantly. Standards have been continuously refined across all aspects, from design and manufacturing to inspection, while corresponding regulatory requirements have also been raised. As the final line of defense for pressure vessels, the proper selection and implementation of safety accessories are therefore of paramount importance. So, what exactly are safety accessories? Safety accessories are safety devices installed on equipment to prevent pressure vessels from exceeding temperature, pressure, or load limits, thereby ensuring their safe operation. They are an indispensable component for the safe and economical operation of pressure-bearing equipment. Selecting the necessary safety accessories based on the specific conditions of the pressure vessel, such as its intended use, operating conditions, and the nature of the medium, can enhance the reliability and safety of the pressure vessel. Common safety accessories include safety relief devices and pressure gauges. Let's now take a closer look at these safety accessories. First, safety relief devices. During operation, pressure vessels may, for various reasons, experience internal pressures exceeding their maximum allowable pressure. To prevent overpressure and ensure safe operation, safety relief devices are typically installed to automatically and rapidly vent the medium from the vessel, preventing the internal pressure from exceeding the maximum allowable pressure. Common safety relief devices for pressure vessels include safety valves and rupture discs. The function of a safety valve is to remain tightly sealed and leak-free when the pressure vessel is operating at normal working pressure. When the pressure exceeds the set value, the safety valve opens automatically under pressure to relieve pressure from the vessel, thereby preventing damage to the vessel or piping. When the vessel pressure drops back to the normal value, it closes automatically to stop the release. Based on their overall structure and loading mechanism, safety valves are commonly classified into two types: lever type and spring type. The structural components of a lever-type safety valve include the valve body, valve disc, valve stem, lever, counterweight, adjustment screw, and locking screw. The mechanism relies on adjusting the position of the counterweight or changing its mass to regulate the opening pressure of the safety valve. Its advantages include a simple structure, convenient adjustment, relatively high accuracy, and suitability for higher temperatures. Its disadvantages are that it is relatively bulky and difficult to use on high-pressure vessels. The structure of a spring-type safety valve consists of a valve body, valve seat, valve disc, spring, and adjustment nut. The mechanism relies on a spring as the loading device. By adjusting the adjustment nut, the compression of the spring can be altered, thereby adjusting the clamping force of the valve disc against the seat and determining the opening pressure. The advantages include a compact structure, small size, responsible operation, and low sensitivity to vibration, making them suitable for installation on mobile vessels. The disadvantage is that the spring's elasticity decreases when exposed to high temperatures. Installation of safety valves. Safety valves should be installed vertically upward in the vapor space above the liquid level, within the pressure vessel body, or connected to a pipe linked to the vapor space of the pressure vessel. Generally, intermediate, shut-off valves should not be installed between the pressure vessel and the safety valve. When installing a lever-type safety valve, the valve stem must be kept in a vertical position. Maintenance and inspection of safety valves. Prior to installation, safety valves must undergo hydrostatic and leak test, conducted by qualified personnel. After passing these tests, the valves must be adjusted and calibrated. The opening pressure of the safety valve must not exceed the design pressure of the vessel. Safety valves that have been calibrated and adjusted must be sealed with a lead seal. Safety valves must be inspected regularly, at least once a year. Periodic inspection work includes cleaning, grinding, testing, and calibration. To ensure that safety valves operate sensitively and reliably and maintain good sealing performance, daily maintenance and inspection must be strengthened. Safety valves should be kept clean at all times to prevent the valve body springs and other components from becoming stuck due to oil residue or dirt, or from being corroded. The integrity of the safety valve's lead seal should also be checked frequently. When temperatures are extremely low, check for the possibility of freezing and inspect the safety valve for leaks. A rupture disc, also known as a burst disc or burst plate, is a rupture-type safety pressure relief device. It consists of a very thin metal plate, held in place by a special flange assembly within a short pipe extending from the vessel. The mechanism operates at a burst pressure, generally set at 1.25 times the working pressure and not exceeding the design pressure of the pressure vessel. Pressure is relieved through the rupture of the disc, after which the device cannot be reused. Its advantages include excellent sealing performance, rapid response, and resistance to contamination from viscous substances in the medium. Its disadvantage is that it is only suitable for pressure vessels where safety valves cannot be installed. A pressure gauge is a measuring instrument used to measure the pressure of the medium inside a pressure vessel. Based on their operating principles and structure, they can be divided into 4 major categories: liquid, column, elastic, element, piston, and electrical. When selecting a pressure gauge, the accuracy class, maximum range, dial size, and isolation device should be chosen based on the magnitude of the measured pressure, the installation height, and the properties of the medium. Maximum range, 1.5 to 3 times the vessel's maximum working pressure, preferably 2 times. Accuracy, generally, the larger the range, the lower the accuracy, and the greater the visual error. Dial size, the pressure gauge dial should not be too small. Its size should be determined based on the viewing distance. Isolation devices, these prevent contact with high temperature, highly corrosive, and condensing media. When installing a pressure gauge, it should be mounted in the most conspicuous location to facilitate observation by operators, with adequate lighting and protected from radiant heat, low temperatures, and vibration. Pressure gauges, installed at elevated positions, should be tilted slightly forward, but the angle of inclination should not exceed 30 degrees. For vessels containing high temperature, highly corrosive, or condensable media, an isolation buffer device must be installed between the pressure gauge and the vessel. For the use and maintenance of pressure gauges, mark a warning red line on the dial based on the equipment's maximum working pressure. Pressure gauges that have not passed inspection or lack a lead seal must not be installed or used. Pressure gauges should generally be calibrated every 6 months. After calibration, the gauge should be sealed with a lead seal and marked with the date of the next calibration or the calibration validity period. In this class, we learned about safety accessories for pressure vessels. That concludes this session. For your homework, please consider the following. Give examples of how failure of safety accessories, such as malfunctioning safety valves or pressure gauges, can lead to vessel leakage and overpressure accidents, and explain the causes. Alright, that concludes this session. See you in the next class.